Alright, now we're done with looking at broken clocks. We're going to be starting delayed clock. So yeah, let's look at this problem. And you're going to see there's going to be more given times. One Sunday morning, Dan notices that his clock has stopped working. So he replaces its batteries, estimated the time, and set the clock to 8 a.m. Now let me ask you a question. Is it really 8 a.m. right now? No, 8 a.m. It actually doesn't really have a lot of importance. It still has some importance. It doesn't have a lot because the problem right now is trying to confuse you. Remember, it said estimated the time. It never said it was the actual time. So he just set it to 8 a.m. assuming that it was accurate. So then after that, he sets out to an observatory, one of the science observatories, because he works there, or was just looking. Anyway, he arrived at the observatory. So what just happened? He went from his house to the observatory. So that's a period of time there. Anyway, he arrives at the observatory and he realizes that the accurate time then at that moment is 9:15. So 9:15 a.m. just to make sure, arrives at observatory. So 1.5 hours later, he sets on back home. So how much time did he spend there? So 1.5 hours later, what time is it now? 9:15 plus 1 hour and 30 minutes. That's 10:45 a.m. So at 10:45, he goes back home. So by the time he reaches his house, the clock is showing the time 11:20. Now, is 11:20 the actual time? It's not, because we know that it was his clock that showed it. And remember, his clock was estimated and it's not accurate. So at this moment, what is the actual accurate time? So when we talk about delayed clocks like this, we need to know that even though we're not given the accurate time moments, the difference in time is always the same. And what was the very first, how much did this whole thing take? How much time? Well, when he went, his clock was showing 8 a.m., right? And when he came back, it was showing 11:20 a.m. Even though these may not be the actual times, their difference was still the same. So to get from 8 to 11:20, that would be 3 hours and 20 minutes. 3 hours and 20 minutes. Meaning that that was 200 minutes in all. And how was these 200 minutes spent? Well, it was spent at observatory, going there, and coming back from the observatory. Going to the observatory and coming from the observatory. So, we know that how much time did he spend there? He spent 1.5 hours there. So he spent 90 minutes at the observatory, giving us 110 minutes left. And going to the observatory and coming back would take the exact same time. So 110 divided by 2 is 55 minutes, and 55 minutes here as well. And notice how I'm setting up this kind of diagram table chart thingy that's helping me organize, and I'm having a clear solution one step at a time right now. So we know that this is how it took 200 minutes in total, and this is how those 200 minutes was spent. Now, what is the accurate time? Well, what's a time that we know? We know that when he left the observatory, it was 10:45. And you can do this with 9:15 as well. I'm just picking this because it's closer. And by 10:45, he has already been at the observatory and he has already went to the observatory. So he's coming back, and it's going to take 55 minutes for him to come back. So how much would that be? That would equal 11:40, right? Because 45 takes another 15 to go up to 11 a.m. So I'm going to take another 15 from 55 minutes. So now we're at 11 a.m. and we add the 40 minutes that are remaining. So 11:40 a.m. So at this moment, the accurate time is 11:40 a.m.